Everything's up and running. So, good afternoon, everyone. It looks like we have a couple participants already on the call. Hopefully you guys, and maybe Nick, you can let me know. You're seeing my screen, right? You're seeing my video at the same time?
Yep. Yeah, I see it.
Okay. This is going to be a live demo for the most part of it. We're going to show you some of the new features with FieldLink and the X7 scanner behind me. If there are any questions during any of this, please type them in. If we could actually unmute everyone, I'd be fine with that as well. But I would like to answer any questions there as well. So FieldLink primarily runs on our tablet here. So the T10 tablet. I'm going to be showing you, kind of sharing my screen from my PC to give you this demo, just so we can see it live. Let me throw out a couple slides first, and then we'll jump into the live demo of what you see as my house scan there as well. So hopefully that didn't close down everything. It looks like it did though, so we'll give it a second to catch up. Sometimes PowerPoint is a little slow. So again, I'm Steve Ostrowski. I'm the sales engineer for the East region with scanning and mixed reality. I was formerly the product manager for the X7 FieldLink, as well as our mixed reality portfolios. An overview, because Steve is not on the line today, the other Steve, but this is really what Building Point Northeast can offer you. A lot of you guys are probably coming to us already using or are currently probably actually users of our field layout technology. This includes our RTS as well as our new GPS 986. These will tell you where to go to lay out and install your stuff correctly. The X7 now works with the same software that runs those instruments and scans. So not only is it gonna actually you can use the laser pointer to lay out, you can actually then scan and register and do all your processing on the tablet, export out as an RCP or RCS, a recap file to send to Autodesk, Navisworks, Revit, or AutoCAD. As well as back to our programs. But essentially everything that you used to need to do with another desktop software on the office, you're doing now on the tablet with the T10 and FieldLink. You're going to be able to scan and view the scan compared with the model. And today I actually have a model I made and created of my house to do a little inspection analysis of. Very accurately, down to an eighth, 16th of an inch. You can also use our other mixed reality to overlay the model out in the field. These won't be as accurate, but are good for QA, QC, site walks, things like that. The other portion that we as the BCSF teams and the Building Point teams can help you out with is our newer one is construction robotics, so kind of automating this. Definitely not quite to the product point there, but very close. So 3D scanning, what is it good for? A lot of times, and this scanner will definitely improve, the traditional way is document the as is. It's doing the pre-construction field measurements and for renovation and retrofits, or collecting as-built if you're doing underground stuff. That's what you traditionally would use scanning for. This is gonna, I guess, improve that workflow and do the registration and georeferencing in the field so that those deliverables are faster. But one of the other huge things we can do is do construction verification. So scan to model comparison, meaning you can use the scanner on new build or as the project's going along to see everything that's being put in. Is it in the right spot? Is it in the right elevation? Is the floor flat? You can do all that now. This is just the kit. Everything I'm going to show you is actually just in the X7 kit with the T10. We do have other software for some other purposes. Cloud Engine, if you want to publish your data so that your clients can view it online or even on their phone here. If I bring this up, it's going to be probably not that clear, but somewhat clear. You can share that, and it will be a little bit lighter of data, meaning we're not going to send all this point clouds up to be viewed on the web, but you can send it fairly easy and then start to see scan data that you can pop into and do basic measurements as well. So that's Cloud Engine. That's good for online sharing so that your foreman, anyone else associated with the project, you can send them a link if you give them access so that they can do basic measurements and see what's been scanned and compared. There's Scan Essentials for SketchUp. That's if you want to bring the scan data in SketchUp to model. It's a good way to do probably site planning more for your GCs for quick, easy modeling from that scan data or from UAV data. If you have that as well, you can bring it in. And then there's RealWorks. RealWorks is going to be our traditional registration software, as well as our advanced and automated modeling software from scan data. So you can actually come in, say, extract out all these pipes and then create model geometry or create mesh objects that you can send to Revit and Navisworks, so that if someone doesn't want an RCP or an RCS to bring in there, you can send them geometry. But those are the 3 other softwares, again, not needed for what I'm going to show you today. FieldLink, kind of one of the big things we're doing is, because we're doing in-field registration georeferencing, we can do construction focused workflows and really do this game to BIM. Or what you're seeing in this GIF is actually multiple scans before and after concrete's poured, grouping. You can see in the red to blue is actually the flat portion of that, as well as the collaboration model on top. So you can do comparisons that we're going to see. The comparisons, and we come out with week or quarterly releases on FieldLink. These are kind of some of the highlights of what we can do and what we released in 5.8, 5.9, or 6.0. I don't really know what they're naming it quite yet. We'll be coming out soon. We do it quarterly. It's been about a quarter, so I don't know exactly when. They usually will have some testing, and we'll get it out to us in a couple of weeks, but primarily it's in the next couple of weeks is generally when it comes. But with 5.8, we've improved, and we improve every release on what people want. The registration refinement, kind of just standard stuff that's been in there. Scan to model comparisons for inspections, like you see on the bottom. Section box viewing is those improvements of how to clip the data, so you're not seeing everything, and then exporting to RCP or RCS more efficiently and faster. The 2 new workflows that we have that we'll briefly touch on is floor analysis, and then we're primarily focusing on the scan to model inspection, or essentially how does the as-built differ from what was designed. We do cover the floor analysis more in our last meeting, our last quick one, but hopefully we'll show you very quickly here. An example of this being used out in the field is actually this are 2 different images. So the top 2 images correlate. This is actually a picture view of, if you can follow my mouse, where that fire sprinkler was installed from the perspective of the scanner. You can actually compare, and what you're seeing here is scan data here in red with a key showing you where it's essentially deviated from the model. So you can start to see that around this portion, they missed an elevation on the install, meaning they're going to run into the HVAC right here with it. So you can catch that, clip it like you see in the section box, and even share that data. Just share with the GC or with other stakeholders on the project how someone's in the wrong elevation, they need to move fairly quickly, that conversation goes. The other thing you can use this for, and what I'll actually kind of do today, is for like wall analysis. This is a 10-story elevator core, and we'll bring open this data, showing you the lean in from the back wall, specifically at the top here, where they're actually 2 to 3 inches in the blue there, leaning in, meaning they're going to be out of spec, and they're going to have to grind so that the elevator core doesn't rub up against it, right? So this is a perspective of the scanner from actually the bottom of it, with some pictures showing you all the way up. If we had some fall protection, we could then actually go mark those points out to go lay them out as well, but we didn't. So we can just tell them, hey, the top 2 floors on the left-hand side, you're probably gonna have to grind down. 2 more examples before we jump in the demo. Kind of a scan to model comparison with the FFFL or the super flat floor that we did here. So we actually did a comparison for an FFFL on the pads here, but we can also just do a scan to model comparison without doing those floor workflows. So here is the model created for the local 404 warehouse where they're doing the super flat pour, and then a comparison where everything in green is within 1 inch of design. So top of concrete was fit really well. And on a live site in an engineering room, here is actually VCU down in Richmond, their mechanical room they're installing, as well as some of the mechanical pipe that was offset or put in, essentially off wrong control a little bit. We were able to scan, see that comparison of being about 3 inches to the south because control was wrong, and then they're able to fix this prefab pipe that's coming in to connect. So you're still, if you do make a mistake, you can catch it before the trucks go out with the new prefab stuff. You don't have to weld that 12-inch pipe out there in the field to fix any of those mistakes. Hopping into the software. So I'm already connected to the instrument behind me. You can see it's got its green little lights on. And I've scanned my house. When you're a sales engineer for scanning, you generally scan before you move in. So before any of before it gets all dirty, I've scanned it, and I've was able to quickly model it in an hour or two in SketchUp. So we have a basic model in the background here that I can turn on. I'm also only viewing the first floor just to make it a little bit clearer, but obviously I scanned the outside, I got the whole house, and you can see a little bit of the extents. We're showing you today is going to be like an indoor workflow. It's going to show the scanner just on my office here, but obviously the scanner shoots 260 feet, 500,000 points a second. When I'm working indoors, I'm probably only scanning at 12, I'm only collecting 12 million points per scan because that takes about 30 seconds. If I'm gonna shoot something larger or farther away, I'm probably gonna shoot it at a standard scan and collect more points so that I get better overview of it. But here we already have the scans already registered. So they're in a coordinate system. If I exported this out as an RCP, they'd pop into the right spot there, and they're registered. So there's nothing else that really needs to be done. I could send just this first floor as an RCP. They're already colorized, pop it into Revit, Navisworks, or even Recap if I want to view them. To show you quickly how, I gotta try and move this, how we do some of this collection though, I'm gonna collect one more scan. Obviously, I collected these scans before we moved in a couple months ago. Time flies. I think it's been more than 6 months now, when nothing was there. So I can jump into the scans to show you roughly what they look like. But obviously, this is before the kitchen was filled up. You can, in these station views, start to take measurements. But I wanted to also show you a couple more things, which is what did this office look like before we got here? So this is actually, because there was no light in here when I was scanning at night, this is kind of what it originally looked like. We're going to scan and hopefully register back to this scan because these walls are in place. So as long as there's some vertical surfaces that are the same, the two scans will match together and tie together and what's called a registration pretty easily. We do have some manual ways to stitch these together as well if you are spacing it out. Now, because I'm in the wall's already up, there's a ton of overlap and a ton of vertical surfaces. I shouldn't have any problems in my office, but if you're outside and only steel's up, we do have manual ways to tie these together if it doesn't work perfectly. So we're gonna go ahead and collect and get to the scanning so then we can do the analysis and be out of here in about a half hour. Like I stated before, I'm indoors, so I'm going to collect 12 million points in about 30 seconds. That other minute I'll explain. If I'm outdoors, if I need more detail on something, I would scan probably at the standard level. That would give me enough to see the diameter of pipe down to 1/8 of an inch if I really needed to remodel it. If I'm just doing as-built verification or something like that, I need a lot less scans to do that. I can also take images with another minute, and they're going to be what you saw in that first one, very high quality if the light is turned on. You can scan in complete darkness. It does not need light, but if I want to take pictures, I do need some light to do that. It doesn't have a flash on it. So we're going to save those settings, and then I'm going to go ahead once it's saved and hit scan. I can place the scan on a layer as well. So obviously I'm not on the second floor, I'm in the office, so I'll keep this on the office layer, and I can turn those on and off as well. But once I hit start, that scan's gonna kick off. Again, that first minute's gonna do two things. It's gonna self-level itself down to 3 seconds, which is incredibly accurate. It's actually accurate than most of our RTSs out there. Meaning you don't have to use a tri-brack. As long as it's semi-level, it'll level itself for 3 seconds. You can scan upside down, you can scan at an angle too, but generally you're picking it up and moving around on this light tripod, gets the tripod we have. The other thing it does is it self-calibrates. Right now it's shooting to its base, doing an EDM calibration, meaning you never have to send it in for calibration. We do create a report showing you the calibration yearly, because you'll probably be asked on some projects to provide that. But this scanner is the first optical instrument in the world to do self-calibration on board, and it'll do that before most scans to ensure that the data is down to that 2 millimeter or 1/16 of an inch range accuracy. So it's similar accuracy to the RTS, but rather than 1 point collection, it's doing 500,000 points. So right now it's actually scanning. There is a rotating mirror on the inside there, shooting out and spraying the room, capturing me and all the other junk and sales engineer stuff I have in here. Once that's done, it's actually going to transfer it to the tablet. It's going to write to an SD card on the unit and then transfer it to the tablet. So you kind of have redundancy of data. The value with transferring it to the tablet, though, or in my case, my PC, is it's going to start to register, meaning you're going to start to, each individual point it's going to collect is going to have a real space within that coordinate system, in my case, within my SketchUp model here. Again, this is pretty much always running on the tablet in the field, so you're saving all that processing time. So if you didn't have a model and you didn't want to do these kind of new build comparison, you're still saving a ton of time by scanning, getting your field measurements done with scanning, and you're saving even more time with the X7 and FieldLink because you're doing the registration and georeferencing before you even leave the job site. So right now it's done scanning. It's actually taking pictures. The scan's going to transfer over and then load in and try and register back to that scan 21. Because the walls are here, it should work. I'll honestly actually break it and just do a scan to model comparison for the walls to show you kind of the lean and deviation of the walls that are here. So I modeled them being completely vertical, completely right angles. But this house was built in 1895, so they did a really good job, but it's not always completely correct. So we'll show you that deviation as well as even some of the pictures on the wall and how they bump out. It's important. I will bring up some other projects showing you this with the mechanical guys or the MEP guys, electrical, plumbing, that you can do this for pretty much any type of data, but I like to show it on the wall here because I'm not in a mechanical room. And the basement here is a little too small to get in, and I guess a little too dusty actually for me to want to hang out down there, and a little wet too. So here's that scan 25, and it's going to try and register back to scan 21. Again, usually this is all in the field and kind of happens automatically. For those times it doesn't work, you can manually actually align it as well too. So we'll let this one try and figure it out manually as well. Pictures are about done. Once the pictures are done, you're picking up the scanner and moving it. Depending on job site and how much detail you need is how far do you go in between each scan. Because the walls are up here, I'm probably popping it in and out. Here you can see I had the door open between the hallway and the bathroom, but usually you'll pop in the doorway here and then scan around. If you're on a job site that's completely open though, you're running in between. You're going 30, 50 feet in between scans. Here you can see scan 25 and 21 are now registered to each other from those walls. Pretty close, obviously, because it's not a very big office. I can then come in and start to look at this data. So unfortunately, they're similar colors. I can view it, but this is kind of, if I view it in this kind of per station color view, it's kind of giving me an idea of what was there and what isn't. So I probably should have tested this out before and shown you without the with another scan that would hopefully come in a different color, but right now they're kind of set for this one. So in the darker green is scan 21, the lighter green is scan 25. I can also view it in colorized as well, in grayscale, and a couple other ways to see what I have. Here, if I jump in, we're going to start to show you the analysis. So after, let's see if I can move this over here maybe. After I've collected those scans, they've registered, I can go through, and I've already done this. We covered this actually with our last demo, but I've already done this once. This is an analysis for the floor. So going through for the entire floor here, let me see if I can jump back one more actually. And turn off the model. I've actually see how my floor slopes in quite substantially. Click on floor 3 here once it's done leveling. It's going to kick it off. So this would be the floor analysis. You can come in here and actually start to see kind of cut fill lines or higher or lower. You can set a reference elevation or find a drain to make sure everything's pushing that way. You can do this throughout the entire job or into a specific room. This floor isn't flat enough at all due to the age of the house to actually do an FFFL. You can. The points would just be bad, but you can actually come in here and start to see and create a report of just those high and low spots here. So this is going to be that surface analysis that we did on the previous one. The next part I'm going to jump into is actually the scan to model comparison, the inspection. I say. So actually we'll cancel that one and just jump right into it because I don't want to take up too much more time. But here is that report. These points will be created with elevations that you can send just as a CSV or get rid of the scan data entirely, just so those are on. Keep the DWG or the grid lines on. Here I have my model outlined in blue, but I could just turn on different layers to show just that. And then it'll give me cut, fill, total volume, above and below, as well as square foot area. But generally, this is going to show where the floor is bad fairly quickly. Moving on to the inspection, or the other function we have in 5.8. This, rather than doing just a scan to model comparison, it's going to do a rather than just doing a level comparison, it's going to do a scan to model comparison. So I've actually already ran through here. I'm going to turn off the model to show you what it looks like for the floor. This actually looks, I think, fairly good for analyzing that floor. If I just do this, I'm actually going to close it down and pop it back open to get that toast out of the way. Disconnect. And then we'll show you that. That's the beauty of a live demo. Sometimes you just get a little bug that pops in. So in order to tap into some of those other functions, I'm actually going to just close it real quick and then reopen it so that toast goes away. But what I'm going to show you is the scan to model comparison of just that flat floor is going to probably show me, I'd say, better visually what's happening. And then I'll show you on the wall and a couple other examples too from some other projects. Let me see, are there any questions so far? Nope. How you place these scans to the model is kind of going to be important. If I wanted to do this very accurately, I would set up the X7 like a total station. I would shoot 2 control points and then scan afterwards. That would place it exactly where it should go. If your setup is good, I generally will actually manually align it, and I'll do that with the second scan, or the 25th scan we did here today, or whatever number we're on. And just do that for a vertical analysis. So 90% of the time, 80–90% of the time, manually placing it to like a stair core or steel is going to work, because you're going to see essentially all the other steel components are lining up. So if you place it to align to that, it should be good. But you'll see which column lines are potentially out as well. So moving back in here, sorry for that delay. I'll go back into the scan inspection. I've ran this a couple times. So one for the entire floor, I can click and then start to view, and I'm going to turn off some of these other functions just to make it a little clearer. So here I'll pump in and turn off the points. So these are actually all the elevation points that are grid line from that floor analysis. I can turn those off though, just so it's a little clearer, and then turn off the model as well. So you can see kind of the middle of the floor bending in, obviously over time. That's where most of the weight is. The floor is kind of settling in. But this is that scan to model analysis that I was able to just run by sectioning down and turning on the different layers that I wanted to compare. Another one would be kind of like this wall analysis as well. And this is what I've done earlier, but we're gonna actually redo here now as well. So you can start to see the alignment is a little crooked. So I can actually turn this off, come back in and re-register the scan 25 to be a right angle to the rest of this. Let me turn off some of these scans and show you that. So turn off scan 21, scan 22. Now we only have scan 25 there. I'm going to kill it and then turn the model back on to finally align and do a very good, I'd say very precise wall analysis of what's behind me. This is going to be, I'm going to change the center of rotation here and line it up. I'm going to essentially try and align this flat wall as best I can to what was designed. So I can get rid of this rotation angle that's there as well. It'll give me a better idea of how accurate that is, because these previous scans were probably aligned to the front wall, or they definitely were aligned to the front wall. So I can't really change that, but I can look at, I guess, visually where it's bumping in and out rather than getting this angle of rotation here. So here I'm just aligning this just so it fits this wall very well. And it'll give me a better idea of seeing the bend of it rather than using the alignment, which is at the front. So front of the house was probably built at a right angle. As they moved back, it curved, meaning this wall behind me is probably at a deviation to the front of it. That's life. I'm gonna have to live with that. But what I really want to see is kind of the curve of the wall. So I don't want to actually look at that bend. And that's why I'm breaking the scan away from the registration at the front and then doing this analysis for that. So it is important to think about that registration, how you reference to something when you're doing these workflows. Again, these are more advanced workflows. These are for when your VDC guys are, and we do have some customers who will have their VDC guys out scanning, so they can do this comparison analysis. If you're just scanning and doing the collection though, you can always do this analysis back in the office later. Bump it in to do the inspection again. It'll save that location. I will then create another section box and run the inspection to show you how that looks like. So here we'll do the wall or section box 5. Maybe this will be a better one. Yeah. Essentially, this is already a created section box. I can push this in and out though, so I can only look at the wall I care about, which would be the one behind us. And then once that section box is set, I can turn on different layers or turn off different layers as far as the other office furniture. So I'm probably going to get rid of the fake desk I have in there, which maybe I can see by turning it on and off there. I may have it on the wrong layer anyways. Frame maybe. So right now I'm just trying to find out where this one is, which looks like it's on layer 0. All right, we'll run it anyways because I don't want to keep spending the time to figure out which one that is. I guess I can do this though. That's layer 0, which I think is also the wall one. But after I have the layers turned on and off as I want, I can run the comparison by just clicking the inspection tool. So what's going to happen now is the really neat part. It's going to compare everything that is scanned to everything that is visible on the model of the layers you have turned on and off. So it's going to show me how the as-built or how my desk and dresser behind me differ from what I modeled in as a standing desk versus that, as well as the wall features as well. So you can start to see the bend. So you can do this inspection on anything. If you have it scanned and you have it modeled, it'll run this analysis. You can see obviously this desk is why you see that kind of highlighted area there. The wall is fairly flat, but I can actually bring this into a finer tolerance. So if I bring it into, we'll say 1 inch, you're actually going to start to see how the pictures are essentially out 1 inch on the wall and how it kind of bends or curves at the top of it, as well as when you get closer to the door, it kind of moves in too, which visually I can actually see over here how that bends in towards the doorway. I did not model the doorway, so everything there is in gray. So any of the scan points that are 1 inch or more away from a model component that's turned on will actually be gray. And then you can see anything that's red is within 3/4 of an inch to 1 inch deviation. And then this light green is within 1/4 inch. The darker green is 1/4 inch to 3/8 of an inch. So you can start to get a very good idea where that deviation is coming in. This is a live demo. That's why I show you this right now. I'm going to show you some other data sets just to do this. This is actually a HVAC example. So we saw the picture of the image that I'm going to open up here, where essentially the HVAC guys were going to install. They had everything kind of laid out within the mechanical room they were currently installing, and the fire sprinkler guys had already started to put up their stuff. But the fire sprinkler guys essentially put it up in the wrong spot, meaning they were in the right XY, which you should be able to catch fairly early, but they were in the wrong elevation. So here, I've already pre-clipped, or we went in, we scanned, we did all that registration and movement fairly quickly and easily then. We then kind of knew where this is going to be a problem too, if I'm going to be honest. Even the guys on site told us. But here is just that inspection between the HVAC model, the fire sprinkler model and the scan points. So everything green here is within 1 inch of design. And so you can see they were supposed to route around the existing steel on this renovation new build university job, but they didn't come up in elevation. So they're about 3 to 4 inches here. They're out of elevation. Now, as they go in, you can actually start to see where they clash back with the other HVAC components that you can bring in. Bring in any type of model into FieldLink now. There is a way to bring in even Navisworks. We can use Connect to bring that in, Revit, and bring in multiple file types as well to do this comparison. If you have the Navisworks, great. You don't need to bring in multiple DWGs, but if you don't, you can bring in your multiple DWGs and IFC models from Revit. One other quick example that I usually like to show is if you don't have 3D models, even if you're just checking because you're putting in the sleeves, you can scan and compare back to a 2D model, which is what this is going to show you as well. So while the inspection tool is great, if you don't have it, your guys out in the field don't have the model, probably couldn't comprehend it. They can easily resection like they've been doing it before, and they can zoom in and start to see just with 2D drawings where sleeves are and if they're in the right location. So in this, I just have a 2D drawing. I can kind of zoom through. Within 20 minutes, I'm able to scan and then do this analysis at the same time to make sure everything's in the right spot. So let me turn this on one more time just to see it, and then turn the outline view on, because usually that makes it a little bit easier to see those sleeves are popping in the right spot. And as we move through the different bathrooms, you can see that as well. So this comparison, again, very quick to do. That's about it for the live demo. Get to scanning and comparing the as-built to the model. Obviously, if you didn't have any model and you're just collecting because you were doing a renovation job, you're not really doing the analysis while you're sitting there, but the scanning and the registration and georeferencing is still going very quickly. But I'm about 3 minutes over time. So any questions? Let's see. Pop it over. We got Mark. Thanks again. I'm sure this will be recorded. We'll probably post that one up. If there's any questions, I actually recognize Mark and Tevin. Please give me a call, Luke or Theon. You send an email as well. We can probably show you this live with more interaction too. So we just did one scan, tied it back in. My whole house took me less than an hour to scan, probably another hour to model. But you can use this at every phase. So thanks a lot, and we'll talk to you soon.